So your goals today, well, we kind of already did the factorial goal. So you guys all know what a factorial is now? Yeah. Do you remember the definition of a permutation from yesterday? I thought it was important. So it's a type of arrangement where order is important. It's given by the rule NPR. So what's the N represent? It's the number to pick from, and R is the number of spots to fill. It is 12, and R is, yeah. Does that make sense to everyone? So in the past, like last week, you would have just gone, oh, this is easy. The first position, there's 12 people. And then the next position, how many people? 11. And then 10, and then 9. And this is exactly the same in this question. The top row is 12 times 11 times 10 times 9 times 8 factorial, yeah? And on the bottom is 8 factorial. So the 8 factorial, what happens? Does that make sense? So either way you get the same answer. If you did the method we did last week, or if you do the method of permutation, the rule of permutations, you're going to get the same thing. For the exam, I want you to do this, okay? So if you get a question like Genesis leadership roles, I want you to show this working out, okay? And then, well, this is the thing. If it's a tech-free, what are you going to do? Just shove it into your calculator. If it's a tech-active, you're just going to shove it into your calculator. If it's tech-free, you're going to do 12 times 11 times 10 times 9. So that's a lot of different combinations just for 4 positions. All right, the next question, slightly harder. Any thoughts? So the number of A divided by the number of all possible. So that's where permutation rule comes in handy to find probability. So what's the number of people that apply? So event A. So it's not the same people can do all 3, so we're not going down by 1 this time. So first person could be 12, could be any of the 12. Then the next person could be, again, any of the 12. And then the next person could be any of the 12. Does that make sense? So the probability, I don't know if any of you went for primary and then middle. The probability, you know, if it was 12 people each time, it's 1 out of 144. So 4 different fruits. I don't know, an apple, banana. What's another fruit? What? Orange and a dragon fruit. Okay. Dragon fruits, not really. How many possible ways how, if it was in a line, the first circle would be A, B, O, D, and the second one would be D, A, B, O. You see that? But in a circle, it's the same, isn't it? You see that? So has anyone got an idea how we're going to change? We still use the permutation formula, but we have to do one thing. Not 2, you're getting closer.
4.
You divide by R.
Close enough.
Okay, so in the fruit one, we've got 10 to pick from. We've got 4 spots to fill, and we're dividing by 4.